Welcome to Networking Field Day 14. We are here with Nyansa, who will be presenting to a group of invited delegates from the networking community who will be offering opinions, discussion, and their perspective on technology. If you would like to learn more about this video, please go to our website at techfieldday.com or check out our YouTube channel at youtube.com/techfieldday.
Fine. So what I'm on is the Voyance dashboard. And basically, I'm actually showing you guys Acme University, which is an anonymized version of a university customer of ours. But it's all live data. And I'll just quickly walk through. This is kind of a roll-up of a single site, right? This is what you guys can expect. And then I'll get into, from a bottom-up perspective, where all of this data and where all this analysis comes from. So the first part of this really is, okay, what's my current incident status? Oh, sorry, what's that? No, go ahead. Oh, okay. What's my current incident status? And that's just sort of a status up there. Is there, and what priority level? Are there any P2 or P1 issues going on at my site at this time across these different topics? Next part of this is just application visibility and application usage, as well as any kind of issues that we see there. Down here is sort of probably things that I don't think you would have seen before. The first thing over here on the bottom left is something we call advisories. So these could be internally generated or externally generated. So an example of an external generated one is Microsoft puts out an advisory saying that these Microsoft Windows 10 clients get stuck at DHCP. Right? They pass everything and just keep getting stuck at DHCP over and over again. And this is the way you fix it. So we can take an externally generated advisory like that and look for that signature on your network and point out whether you have any of that known problem, right? An internally generated one would be something like, okay, these are the authorized DNS servers in my environment, right? Look on my environment to see if anyone's using any kind of unauthorized DNS and tell me who those clients are. And let me see that. And so that'd be an example there. The thing in the center here that's called problematic clients, it's sort of our first step into enabling IT to be proactive. So what we're doing here is actually, these are all client devices that may or may not have, like their users may or may not have phoned in and said we had a problem, right? But what we're trying to portray here is that we've been staring at these devices and looking at the problems that they've been having. And we've noticed that these guys have had problems over and over and over again, as we've seen. So, if I expand this guy, for example, right, this device was on the network in 159 different hours in the past 2 weeks, right? And all 159 of those hours, this client had bad Wi-Fi performance, right? So he may or may not have called in and complained, but we've actually noticed that he's been having these problems, so you can actually go and reach out, potentially, in an enterprise setting, as an example, right? And you can actually, I think the Zoom kind of messes this up. One second, let me zoom out. So you can actually specify here, you know what, I want to look at radius issues in particular, or DNS, or internet issues. I want to look only at laptops. I don't care about phones. I don't care about anything else. So, I'll do an example here, right? So internet performance just for laptops. Let's just take a look at that. And then now I get a filtered list over here. And the same thing, right? So I see, okay, this client, 32 hours, 19 of them, he had slow internet, right? And so it's just the ability to say, you can actually reach out to these clients when you're not getting reactive calls and say, hey, we've noticed that you've been having problems. Can I help you out, right? Or let's try and figure out what's going on here.
One thing I just want to ask and interject.
Yeah.
Part of what I do at Nyansa is go around and I talk to our current customers and prospects. How many of you are seeing IT departments that are wanting to be more proactive and putting an effort into being proactive? It feels like a theme with things I've kind of heard more recently than maybe in the past.
Yeah, no, there's a lot of conversation about proactive versus reactive, and let's be proactive and not reactive. That's a huge deal right now.
Okay.
Yep.
Okay.
Yeah, any questions, comments, by the way, so far?
And just, again, I'm adding.
Yeah, sure, absolutely, yeah.
These advisories, we've seen that some of these client Mac OS 10 radius performance, you can get a list of all users that are having that problem, and you can email them. So you can actually export a list right from Voyance and say, here's all the users having that, and then you could use that to generate an email, and say, hey, you need to update, and here's why. Yeah. Yes, sir?
So you guys are saying that you're really concentrating on user experience at the access layer. Are you gathering, or are you thinking about gathering information from the actual client?
Ah, I see. As in like instrumenting the client?
Right.
So, our motto is to try and be like as frictionless as possible. And so we decided not to go that route in terms of building a client agent. So far, that's kind of what we've stuck to. But I mean, maybe in the future. But I mean, what we find is that, that adds a lot of friction, right? Because typically it's like, especially in the day of BYOD, where people are bringing all sorts of different clients, for the network engineer and network operations to try and get all the clients instrumented, it's a bit of a haul.
It's a huge sales advantage for us. Just sheer deployment is 0 to Tesla's Fremont office up in an hour. And that's kind of normal for us, is that from 0 to crawler deployment. The biggest problem we see in deployments is people not knowing how to do a span because they just haven't done it in a while. But other than that, it's really about as frictionless as you can get. And that's a big advantage for us to get into POC and actually make, sales. We would love to do an agent. Sensors would be awesome. The truth is they just don't. People just say, the data's great, but no one deploys it, or very few people deploy it.
So in this example you're showing here, can you go from, okay, I've seen that this client is having an issue, to root cause?
Sure, yeah, so let's check this one out, right? Or, okay, let's use this guy. So clicking on details takes you to that client. And basically, we list out all of the different issues that we see, right? So Google Mail, web. Web was the one in particular, right? That, basically if I bring this drop down, you can see all the different hours in which this client actually had that problem, right? And so that's what led us to say, hey, he was on the network 32 hours, 19 of them or something like that. He had problems. And this is what we do in terms of root cause, and I'll show you guys more examples of this. But the idea for us is when we measure a problem, right? So we decide that this client has poor internet performance because the round trip time to reliable websites, his latency basically, right? To Google, Facebook, those kind of websites was really long for over half the time in the hour that he was using those devices. So we kind of smooth it out. At the same time that was happening, we check other potential root causes. So his Wi-Fi performance, as an example, right? And we notice here that his Wi-Fi performance was actually really good at that time. So his signal to noise ratio, his layer 2 retransmission, channel utilization, things like that, right? So what we conclude here is, it's probably an internet link issue. It's not a Wi-Fi issue. Whereas if this Wi-Fi was X and we kind of knew extra information about it, then we would conclude otherwise. We would say, hey, we think this guy has slow internet, but the reason the slow internet is happening is because of poor Wi-Fi, and specifically X, Y, and Z. And I'll talk about more examples that way in a sec.
And again, I just love repeating what he said, but it says the access point is transferring data great to a lot of other client devices, so it's not a Wi-Fi infrastructure problem. So again, it's just a process of deduction on, thousands of client devices all the time.
In this case, with the round trip time issue,
sure.
Are you able, if you had data from 2 sensors, would you be able to distinguish that, it looked fine near the core, but looks terrible at the edge?
So as we add more symptoms, that would kind of fall out naturally, right? So we might have a symptom here that says, what does average latency look like at the core? What does average latency look like?
For the flows that you watched, though, if the latency is being introduced near the edge, you have that data, right?
Right. That's true. We don't do it.
It seemed like we jumped to a conclusion about it must be internet.
Yeah. Well, in this case, it's because of the lack of symptoms, right? So, part of being as frictionless as possible, right, in terms of, okay, we take deep packet inspection data, we take information from the wireless controller. Actually, a third thing that we didn't talk about is we take information from other enterprise systems too, like Cisco UCM or Skype for Business. They actually have an API which gives you detailed quality data. And so we can actually correlate that. But as we add more and more things that we take data from, you can get more and more symptoms. So basically, for our root cause, we're limited by the symptoms that we collect. So as we add more and more symptoms, we get a better set of metrics to say, okay, this was bad, this was good, this was good, this was bad, and those together point to this root cause versus this other root cause.
And that's a natural part of evolution of the product, right?
Absolutely.
It's just adding just more and more data to get more granular.
Exactly. Was there another question, or? Okay. All right. So last thing on the dashboard, and actually I'll go into a lot more detail about sort of how we break down root cause and sort of figure out what's going on in a system. But the last part of this is just a roll up of this is a big campus or a big university. What does this look like from a building by building perspective? How does that break down? And this example is by Wi-Fi. And the idea here is, okay, so this is a sorted list of all your different areas or all your different buildings. In this, 16% of clients have bad Wi-Fi. So what that's saying is that when 122 clients connect, 16% usually have bad Wi-Fi in this area. And then what this is saying is that these are the applications we see used there. And of those application issues that we see there, that percentage is caused by bad Wi-Fi. So the symptoms that I just showed you, that percentage have some kind of Wi-Fi related symptom, as an example, right? So this is just kind of a location roll-up as well.
So going back to the thing you mentioned about the custom apps, so I'm in my enterprise, I've got
Yep.
my custom apps, because
Yep.
nobody has custom apps in the enterprise.
What's that?
And so I said, because nobody has custom apps in the enterprise, right? Yeah. So, you go back to this kind of analysis, and I can see, okay, if we all get together and we get on our
Yep.
30-person conference call trying to figure out where the problem is.
Yep.
And so I can see, okay, the app is fine,
Yep.
it's the Wi-Fi.
Yep.
Everybody's crowded around that AP, and that's why everybody in this department says, everything's awful.
Absolutely.
And that's what,
Yep.
even with
Yep.
the custom apps, you can
Yep.
kind of get to that end result.
No, absolutely. So custom apps would show up here. But yeah, I mean, let me get into how we look at sort of solving or taking an incident or taking an issue and getting to root cause. Because we actually look at it in an interesting way, I think. We split out issues into short-term issues, so issues that happen over just a 1-hour period, where what you're really looking for there is a deviation, and then, oh man, I care about it because it deviated from my baseline, versus a long-term issue, where what I really care, I don't care about 30 minutes worth of data or an hour worth of data. What I care about is, let me look at this over a week or a month, and let's see what the patterns are in that data, and what are the things that keep repeating over and over again, so I can draw some kind of conclusion. So, in the example you brought up, a custom app, maybe a single instance of it isn't enough to prove to anybody, oh, you just got lucky, your Wi-Fi was good at that time that the custom app was bad or whatever, right? Or vice versa. On the other hand, if you had a long-term analysis of that custom app, and you could say that, every single time this was bad, it was always because of Wi-Fi, or 80% of the time it's because of Wi-Fi, that's a much stronger argument to say, okay, this is what we really need to improve that custom app's performance. So, and with that, let me that's a good segue, I think, actually, to dive into some of that long-term analysis. So this section of the product, so now I'm kind of doing a little bit of a bottom-up to show you guys where some of this data comes from and how to get sort of detailed analysis. What this is showing you is, in my environment, across this university, at a snapshot, what are the systemic issues that I need to focus on, right? What are the areas that I need to improve? What are the areas where I'm doing really, really well, right? What does application performance look like? What does capacity look like in my environment, right? And for each of them, we sort of rate it red, yellow, green, that kind of thing. And I'll talk about sort of where this comes from, right? And again, I'll just use Wi-Fi as an example because it has the richest set of symptoms in a lot of ways to show the different root cause analysis and all that kind of stuff. So let me click into this, even though this is actually a good issue. But I'll show you guys why we labeled it green, as in this is not something that they need to care about at this university, right? So the first thing when I click into this, so it sort of takes me to a detailed page about this particular metric, right? Now, I could have clicked on I could have used a lot of different metrics, and you'll see the exact same analysis. So I'm just using this one as an example. But the first part of this is a baseline. So what this is saying is, okay, what percentage of my clients, so actually let me just expand this for a sec. GT made this point earlier. We take great care in baselining in terms of setting a usage level, right? So what you want to know is when a certain number of people use the network or use something, Wi-Fi as an example, when 882 clients use Wi-Fi, what percentage of them have bad performance, right? because you want to get rid of the times at night when there are like 3 clients on the network or whatever, or the times on weekends or that kind of thing, right? You want to just fix it at one. You might want a baseline for night. You might want a baseline for the middle of the day, but that's what you get here with this usage. So first things first, you get this baseline. In this case, it's around 10 to 12% thereabouts over the last month. GT had mentioned annotations. So here's an example of, we actually stare at configuration, right, and do diffs. So we automatically detect when there's any kind of configuration change that might affect this. And whenever we detect it, we annotate it and automatically do sort of a before and after comparison of the baseline. So this is sort of, the notion of, I made a change. How do I prove that it actually made a difference? And this would be the way to prove it, right? Because the annotation came up before the baseline was X, and afterwards it's Y.
How are you getting configuration information?
By reading it from the controller, from the wireless controller. Yep. So that's part one. Part two is 10 to 12% for this, is it good or bad? So how do I know that this baseline, do I need to spend effort bringing this 12% down to 0? Or is 12% actually a good number, and can I move on to more important things, right? And the way we answer that question, and that's what the green circle from the previous screen was, sort of citing this one as an area of excellence, right? The way we answer that is we say, okay, Acme University in this case is a university for starters. It runs Aruba networks, and it has around 15,000 wireless clients in a week, right? So what we say is, okay, let's look at other university environments running Aruba that have around 15,000 wireless clients, and let's see what they see as their average wireless performance baseline. And again, this is done for every single type of metric, right? So, if we're sort of to look at some of these guys, here's a site, right? Their average is 26%. They have around 14,000 wireless clients. Here's a site, the worst one. They have 8,400 wireless clients. So it's approximate. We try and get as close to your site size as possible, but it's amongst our customer base, right? So, for enterprise, actually, we have a lot more sites, so we have a lot more comparisons. But in university, we try and get close. So in this case, you see sort of, these are sites that are similar to you. And what's the median of those sites? Are you better or worse than the median, right? So we say, okay, the industry benchmark is around 19% for this baseline, or for this metric. And you guys are down here at 11%. So we're going to conclude that you're actually fine, right? So 12%, 11%, the number doesn't mean anything. The fact is that you're okay, right? So you don't have to spend any more time on this if you don't want to.
So why do you assume that because you're better than everyone else that you're good?
I was just having this thought. I'm a networking consultant that goes into a lot of shops. I don't know that the average would be my baseline.
Okay. So you'd want like a stronger, like you need to be like, top.
I want to be at the bottom of that list.
Okay, I got you.
Yes.
Yeah. All the way there.
Well, is there a way to tag what we would call sensitive clients? Users, for example, that need special attention, VIPs and,
Waiting.
I don't really care if they're getting, if they don't meet some special baseline. I really need them to have an exceptional experience.
I got you. Yeah, no, absolutely. That's something we're working on, actually, the ability to tag VIP users. This one is more broad, or high, what do you call it? Across the whole site, if you will, right? As in, just saying that your site, your university in this case, is it good or bad? So yeah, we do make the assumption that the median is a good mark. Mm-hmm. But yeah, it's fair.
No, to be fair, if you're much worse than the median, then you really want to get on.
Well, absolutely. Exactly. There's a clear negative correlation, but the positive correlation may not necessarily be.
Exactly.
We try to take the glass half full.
Do we need a consultant filter option?
Yeah, there you go. Exactly. So this is one view. The other view, by the way, is you could actually get the same kind of internal comparison now, right? I can do this by operating system as an example, right? So in Acme University, what's the comparison of wireless performance across different operating systems? And so now this changes, right? So what it showed me before was a comparison of me versus external sites similar to me. When I pick a filter here, it's within my environment. what's the comparison between these various things. I could pick RF band, and that'll give me a comparison of my performance on 2.4 gigahertz versus 5 gigahertz, and so on and so forth, right? So you can sort of slice and dice and compare this data in your environment in order to get all sorts of insight.
And you can, maybe you said this and I was on
Sure.
Reddit, but you can export any one of these PDFs as a PDF as well.
Sure. Yeah. So that's, let me kill this filter here, and let me get back to the rest of the analysis and getting to root cause. And so I had mentioned earlier, it's like, what you want to do with issues of this type is you want to look at them over a long period of time. And you want to see what the patterns that are repeating themselves over and over are, so that you can come to some kind of conclusion. So what this is saying, and so this is the way we measure it. In the same way that in that problematic clients widget, we talked about this client has used internet for 40 hours in the last 2 weeks and was bad 30 of those hours. What we do is we do that for every single metric, and we introduce this notion of a client hour. So it's like if one client has bad performance in 10 different hours, then that client has 10 bad client hours of problems, which is the same as 10 clients having 1 hour worth of problems, right? And what we do is we collect them all up over the last week. So we say, okay, for wireless, this Acme University had 51,000 total client hours of bad Wi-Fi across all of its users everywhere in the environment. Now, how do those root causes sort of distribute themselves? Like what was going on with each of those client hours? So what we're saying here is 36% of them, what was happening is that the clients were on 5 gigahertz, and there was interference near where they were located. And the way we conclude that is just the symptom that we saw was high layer 2 retransmissions, but we did not see high levels of noise. We didn't see high channel utilization. We didn't see that the client was roaming or anything like that, right? So all of the other symptoms were positive. This was the only symptom that was negative. This one is just the access point that he's connected to didn't have DFS channels enabled as well. So that's an additional indicator to us as well. But the idea is it's the group of symptoms that map you to a particular root cause, right? The second most, interestingly enough, was actually noise related in this environment. So what was happening here is that for 14% of these client hours, when these clients had bad performance, the access point that they were connected to had high levels of noise, right? The third most root cause, let's see, was interference, but these clients were on 2.4 gigahertz, and so on. But let me jump back here to the noise root cause. So what this actually lets you do, first off, it lets you quantify what the problem is. So, I mean, I don't know if you guys see this, but people have guesses about what problems are, and a lot of the times, either they know or they don't know what they're talking about, right? And so, in this university environment, it could be like, look, all our problems are because of noise, right? We need to just, go overhaul what we're doing and, make changes to get rid of this problem, right? But this actually lets you quantify that and say, well, noise is a significant problem for us, but it's 14% of the problem. So we could try and do that, and we could probably make a lot of benefit or get a lot of benefit there. But this is how much benefit that we're going to get. We shouldn't fool ourselves into thinking if we do this, we're going to solve the whole thing. But that's the idea here, right? And you could apply filters and do deeper analysis here as well. So, any questions, comments here?
I've got a question about your baselining. So what happens, if let's say you have a retail client that goes into a more extended baseline shift. So Black Friday hits, and suddenly my baseline is way different than the rest of the year for the next 2 months.
Yes.
And then I go back to normal.
Yes.
How does that look in Nyansa?
It's tricky because that usage level will only have happened that one time.
Right, but at the same time every year.
Exactly, at the same time every year, right. So it's very similar to large public venues like stadiums.
Yeah.
So you'll have like a hockey game or something like that. And then you won't have that usage level until the next hockey game. And then the next one after that, right? So we're trying to work on sort of, picking out specific high usage events and being able to just compare those events to each other. Because the baseline, to your point, will be very sparse if you try to just baseline that, right? But yeah, that's a tricky use case for us that we're working on, where it's like one event and then you don't get that event until far later. Or football games are similar. You only get 16 or 8 of them, I guess, if you don't make the playoffs. So, but any other questions, thoughts on this? Okay. So, as I said before, Wi-Fi was one metric. I could have, Dropbox as an example, right? You can do this for anything, literally, right? So you get a baseline for Dropbox. Down here, you get similar analysis, right? You can do comparisons by operating systems, all that kind of stuff. You can say, okay, Dropbox slowness, or this would work for your custom app as well. Example, right? You have some billing app or something that would show up in that list, and then you select that, and you can sort of figure out, okay, when those problems happen, what percent of them were because of Wi-Fi, what percent of them were because of something else. One of the symptoms we're looking to add is also simultaneous application usage. To your point, right? Was this guy using another application that was hogging bandwidth or something like that, or causing slowness, right? And that would be another symptom, like simultaneous app or something like that. And then maybe we blame that instead of blaming something else. So, yep. Okay. So, this is one piece of it. The next part of it is, as I said, we divide things in long term as well as short term, right? So if I click over here, there is an incident view to all of this as well, where I think we had talked, or GT had mentioned it as well, where if something deviates from a baseline, you would get an alert, right? If it's high enough priority, right? So this is kind of, where all of those incidents sit and their priorities. And so, over the last week, these are all the different incidents that we saw over here. I'll use this one as an example. Clients could not connect due to radius. So this was a P3 level importance issue, which isn't that high. I mean, it has to get to P2 or P1 typically for someone to get an email. But why was this P3 as opposed to, let's say, P5 or P6, right? The reason for that is, okay, well, when did this happen? It happened 7:15, 8:15 a.m. On the 12th. 43 out of 2,700 clients were affected. But the reason it became P3 is it's almost twice the normal baseline, right? And so as I talked about before, the way we do baselining is this incident in particular, right? What we do is, historically, what does it usually look like when the same number of clients try and use radius in this case? So when 2,700 or thereabout clients try to use radius, we expect, if I go back in time over here and look at this baseline, we expect around 0.9% of them to fail to connect. Now all of a sudden we saw 1.6% of them fail to connect, right? That increases the priority, right? So if in theory this was a P2 or P1, you would have gotten an email. You would have used the email. You would have seen actually this summary on the email. What are the top client priority or properties and all that kind of stuff. But additionally, down here, you actually get an exact list. So first off, you get what we think the root cause is, what symptom we measured. But you also get the exact set of 43 clients that had this particular problem, right? So you have the in-context information at that particular time when this thing happened of exactly who these clients were and what was going on with them, what server they were talking to, what AP group, and all that kind of stuff. And so you can click on any of these clients and get detailed info, right? And so in that way, be able to drive to root cause, via this. But this is the short-term sort of a network operations or incident-based use case that we would see. But any questions, thoughts here? Okay. All right. So the last thing is, our second last, I guess, right? Is everything is searchable, right? So there's the help desk use case as well. So I just looked up a client that usually has problems. You can use a host name, username, anything like that to search the product. This is just a host name that I found. You can come to the client details page. Actually, we had been to this page once before. But basically, what you get to see on that page is a summary of anything we detected for that problem. So let's say it's help desk, and this client calls in with a problem. You say, okay, let me type it in. Let me look it up. And come to this client details page. This is what we think happened. Okay. We detected that this client could not connect due to radius, or DNS, I'm sorry, right? But the root cause was actually a bad DNS server. So a misconfiguration, I'm sorry, right? On the client side, nothing to do with the infrastructure, right? Now, where did that come from, right? You can always view additional info. So the raw data that we collect We don't hide it. It's all in the product. You can always access it. And the idea is the raw data for this particular type of incident lives over here in what we call an event timeline. So for every single connectivity event that a client goes through, we measure and track that, right? So over here, you can see the evidence. In this case, this is what happened, right? At 4:36 and this time, the client successfully did DHCP. Well, actually not successfully. It seems to have kept redoing DHCP. But he successfully did ARP. But DNS, he was trying to talk to 192.168.0.1, right? And so the symptom that we looked for was, does the DNS server that he's trying to talk, first off, he failed connecting because we never saw him pass DNS, right? He sent requests and he never got a response, right? And we timed that, right? Then we look for symptoms, right? We look for, well, was the server that he was trying to talk to, was that the server given out by the DHCP server? Or is that just some other server like this, right? And that's the symptom that popped up where it wasn't the same as what the DHCP server gave out. And so that's why our root cause or whatever was what we cited. Right? So the idea here for help desk is, if we detected it, great, you get it like this. But even otherwise, there's information here in terms of tracking events, tracking client state, right? What access point he was on, what connectivity state. There's raw metrics as well that I just haven't showed you guys, but it's all there. Like all the raw data that we collect is all there. So you can collect data.
Builds up to the question.
What's that?
The logic that builds up to the question is actually in the site.
Exactly.
It's all there.
It's all there. Exactly.
So if I need to query that and say, why are you diagnosing a DNS server, the level 2, level 3 person can get into that and start to dig away at it.
Exactly, and maybe they can collect information and then put that in the ticket and escalate it, right? If they can't solve it. But yeah, that's so the idea for us is three main use cases. Help desk solving an issue of a client, right? And that sort of makes the basis for everything because everything starts from a single client, all the connectivity, all the apps that he uses, all the performance metrics, everything like that. Then we put that information together and make baselines. That's what allows us to solve the incident use case, where something deviates from a baseline, you get an alert, and you come back into the product because of that. Then we aggregate that info together, look at it over longer periods of time, which lets us do that systemic issue analysis where we can see all the client hours that happen over the week, what thing repeated itself, what root cause is, and sort of be able to say something about that. And then finally, the industry benchmarking, where we can look at other similar environments and sort of say something about how you compare, right, to that industry benchmark.
So I'm in the enterprise.
Sure.
And there are a plethora of monitoring visibility products. So when I look at a solution like this, and I'm also looking at flow monitoring security tools. We've got SNMP monitoring tools. We've got, we've got some of all of that.
Yeah.
Where does this fit in that space? And what's your best argument for this tool over other monitoring solutions that, for me as a network engineer, this doesn't give me interface utilization statistics. It doesn't give me a lot of what I'm used to seeing. What's the argument for this when it's stacked up next to all the other products that are out there?
That's fair. So the biggest argument for us is that the whole thesis which the company is based on is that the access network has become dynamic and heterogeneous. Right? It used to be everything was company issued device-wise. You plug it in. And if bad performance, okay, let's add more ports or more switch ports, right? Add more speed. Applications were on premise, right? So you didn't have to worry about this internet link stuff. That's all changed, right? Now you have BYOD. People bring in whatever device they want, right, and expect good performance on it. That stuff or those devices connect over wireless. They don't even have Ethernet jacks on them, right? And those things are accessing applications that could be on premise. They could be in the cloud, and either way, you're expected to sort of make sure that they have good performance, right? And so the thesis is the access network has changed, and in order to figure out what's going on when you have issues now, right, where I can't access this application or this application is slow, right? most of the problem is actually on the access network side. For instance, if the person couldn't even connect to the network, it has nothing to do with the application, right? And so in order to do that, you need to take a user-centric perspective. You need to track on a user-by-user basis what his experience is, right? Can it connect, right? What applications is it accessing? Are those applications slow? And at the same time they're slow, what else is going on with that particular user? And then you have to take all that data and analyze it, right? Because no one wants just more data, right? Or more raw data. It's the analysis side of it. So what I would say is that we take a user-centric approach, so we're taking real user traffic and analyzing it. And then the second part is the analysis itself, where we want to get to with this solution is actually to enable proactivity at the end of the day, right? So, I've showed you a lot of actually, you kind of have to know what questions you want to ask of the data. You kind of have to know, I want to look at Wi-Fi performance or DNS performance, and I want to sort of slice it by operating system because I have a suspicion that's going on there. Or I want to slice it by this particular DNS server and see what's going on. That's a question that you come into the product with. But where this is going is we want to also propose questions that you may not even have thought of. It's like, this is what we've noticed in your environment. From a Wi-Fi perspective, we've noticed all these client hours sort of focusing around this cluster of access points. And the root cause of all of it is co-channel interference on 2.4 gigahertz. So we want to be able to propose to you, say, you know what, if you turn off 2.4 gigahertz radios around this access point, you can mitigate this many client hours worth of bad performance. Now that may be wireless, that may be the custom application, right? You can mitigate this many client hours of bad custom app performance, right? And sort of give you guys the ability to, both, if you have a question, you can answer that. If you don't have a question, then you can kind of see some analysis that we ourselves have surfaced. So that's kind of how I see us.
Yeah, I have a use case in mind, and I don't know if you guys have done this or if you've looked at it, but we are often in acquisition mode.
Okay.
We go in and we acquire somebody, and really no matter what we say, a lot of the brain trust is out the door as soon as they can go.
Okay.
Right. So now we bought them, we have their stuff. We're responsible for their stuff. We don't know what they use. We don't know what applications they use. Yep. We don't know, is there a way, and have you thought about designing the system to help understand the environment from that perspective? Like, what are their critical applications? Help us to understand this completely unknown entity to us so that as we try to assimilate them, we can do that in a less disruptive way.
So actually, it's a perfect segue to the last thing that I didn't show you guys.
Great.
Oh, by the way.
Did you show them the timeline in this client section?
Yeah. Which time?
The select a time at the top.
Oh, no, I didn't.
Okay.
That's nice. So for anything, so there's inventories that's kind of how we view it of, application services, network infrastructure and stuff like that. For any application, there's just, the way we view this a little bit is just basic visibility, but it's critical to your point, right, about understanding what's going on in a particular environment. And so these are applications that we detect, how many users were using it, what traffic. For any of these applications, you can kind of click on them, get a sense of exactly who the users were that were using that app, how much traffic each of them were sending, right? This would sort of indicate whether we detected any kind of incident in terms of, hey, the performance was slow or something like that for that particular user on that app. So there's sort of a visibility component here as well. Same thing with, on the network side, if I click over here, you have a list of all these access points. If I clicked on one of these access points, for any given time, you can know exactly who was on this access point, right? Were they having any kind of wireless issues, in this particular
Can I
case?
tell what applications they were using also?
On this access point?
Well, what applications, I've got these clients on this access point or at this site.
Yeah.
What applications are they using?
Yeah, so we don't marry those two today. It's a good.
Well,
it's a
she
good
just wants to
use
know
case.
what the applications are running. So
yeah, so
if you just go to applications where you were, then yeah, that shows it.
No, sure. It shows it at a macro level, but a natural next question might be, but what level of application usage is on this in this particular area of my environment or on this access point or something like that.
Yeah, I mean, I
We
would
just
need to
haven't
know that
gotten it-
like per
gotten to it
site,
yet.
not necessarily.
Yeah. Oh yeah. So this is by site.
Okay.
So in this environment, this is all your application usage, and as I said, you could see all the users and traffic and all that kind of stuff. But we kind of view that as visibility. I mean, critical of visibility, but visibility.
Can you put in custom application signatures, to Kevin's point? Like, we've written this custom clinical application 20 years ago.
Oh, totally. So I'll show you guys over here. So this is where you'd configure it, right? So custom applications, you'd sort of put the name in, and you'd say, okay, it has to match this host name or these
Port
sets of
protocol,
IP addresses or ports or whatever. You put that in there, and then the minute you put it in, you get this, obviously, but you also get all that analysis that I showed you before, where you could see the baseline of performance, you could see what the root causes were and all that kind of stuff.
Yeah, I think this combined with real-time user monitoring and looking at changes as applications are being deployed, because that's kind of my domain of expertise, to be able to correlate all that together gives that end-to-end picture that you may not see, the edge network, or you may see a new release of code that has caused problems, or a cache needs to be warmed. To be able to pinpoint that quickly, kind of the needles in the haystack, is pretty valuable.
We just had a customer that we were talking to, and it's like, when everything is down, they don't need us for that. When they need, when everything is perfect, don't need us. That middle ground is the tough part to really figure out, and that's where they said that's where they see the value is, like you said, a whole bunch of needles in a big haystack.
Can I ask a deployment question? Are you more of your customers using it in the campus, or you're more in the data center, or more in the WAN? Is there a sort of sweet spot, or is it
campus? Campus. So this is all about the access network.
Yes.
Right. Clients and users.
Managing large number of disparate, where it's very difficult to gather, 10,000 users. How do you pull signal out of the noise? That's really where your sweet spot is. Today.
And that can be 10,000 users across 100 sites.
Right.
But not in the data center, not over WAN.
Right.
So just the smaller large campus or multi-site campus.
Right. And that's today, to your point, right? I mean, we have plans to.
I'm sure you've got plans. I was just trying to get a sense of where the sweet spot would be, because, this would be very interesting to see it applied to containers, right? Where you've got apps being deployed in containers, and the containers come up, go down. You actually need to get signal about which containers are, if you've got a slow deploy, or, you suddenly got a container come up and somebody's configured the IP tables wrong, or blah, blah, blah. There's so many things in containers that, people get them wrong, and then the deploy goes skewy and blah, blah, blah. So, but that's not inside your scope. I think that's what I was just asking, is making sure I understand the positioning.
Yeah, definitely. I mean, it's interesting that in the data center you could view users as servers or containers or virtual machines, but there are very different use cases in the data center.
Yes,
right? It's all multi-tier application.
And this is a pain point where the cloud is needed to do the data crunching. Yeah. So you couldn't even do this on. Tell me if I'm wrong here, because this is a gross assumption. You couldn't even do this on-prem because you wouldn't be able to crunch the data.
No, we can do it on-prem. So that's, I mean, I think the question was brought up earlier about sort of regulation and compliance and stuff like that. So we are releasing a hybrid SaaS, what we call a hybrid SaaS version of this. But the idea there is it would sit in a private data center. That's how it would be deployed.
Okay, right.
Right, so it was just our backend in the private data center. That backend would get updates from our cloud, right? Would sort of get, send back monitoring and things like that, right? But the idea is no personally identifiable information. Some customers are very, sensitive about it, right? None of that would ever leave their premise.
Okay, right.
So I think you had a question, yeah.
Yeah, sorry. You had mentioned earlier that the finger pointing sessions where everybody gets in a room to figure out what's going on. Is there like a confident demarcation point where you can say, we can say it's not the network's fault because obviously you're not instrumenting the application stack, so you're not like looking at system calls and stuff to find out where their slowness is, but do you have a demarcation point where we can say, we're pretty confident it's not the network because of?
Got it, yeah. No, I mean, we kind of use correlation to sort of make that determination. We say, okay, well, most of the time we've looked at this thing over a week or over a month or whatever, and every time the application is slow, this is what we've noticed on the network. And that's why we're confident one way or the other. Now, for certain types of applications, and this is sort of an area that we expand or that we plan on adding to as well, we do get info from the application server itself. So Skype for Business is actually a really good example of this, where Skype for Business used for, whether it's calls or screen sharing or all of that kind of stuff. They have a push API from that service that we actually read directly from. So that's an application server telling us that this user made a call to this other user, and the MOS score of that call was this. These were the error codes that happened on that call. This is what's going on with jitter, latency, all that kind of stuff. So we get that data directly from the application server itself. And then taking that and correlating with the network is actually quite powerful as well, because then we can be very confident in saying, no, this is definitely the application because the application server told us so.
Wow, can you do that even over the internet? Even over if you have, let's say, a hosted voice provider, that wanted to know the quality of the calls that were coming into a hosted voice provider, because that would be huge. I know a lot of those guys that would love to know that. They're like, people are yelling at me because my phone calls suck. Yeah. But, why is that?
Well, it's interesting. So with Skype for Business and Cisco UCM, we get from the app servers because they've packaged it in an API and sort of collect it.
Sure.
If you don't have that, then we do detect those apps on the wire as well. And we do some level of analysis. So let's say Google Hangouts, for example. You see it on the wire. You can identify that this is Google Hangout traffic or Google Plus traffic or something like that, right? You can see what the TCP, latency, retransmits, that kind of stuff on that traffic. So you can make some conclusions, but then, you don't get the same kind of fidelity.
So certain platforms give you that added visibility into like MOS scoring and things like that.
Exactly, right? Because that's what you ideally need, especially for call quality and stuff like that. Because you need to know the codec, you need to know what kind of device and microphone.
Right, because like at the transport, some of the best systems will tell you the MOS score, not just on one end, but it's going to tell you this is what it was at PBX and this is what it was at the client side.
Exactly. Yep. So, and additional information like, all the internal calls, for example, at a certain level of quality, but the internal to external calls that went over the POTS or whatever, right? They had bad performance. And now, you can slice and dice and sort of differentiate that data as well.
Gotcha.
Yep.
Any other thoughts or questions?
Here in your applications, where you have TCP, UDP, is that just unidentified traffic? Or?
That's everything. So the thing is, from an app ID perspective, the way we looked at it initially, at least, was let's focus on business apps that people would actually care about. Let's not identify, CNN and like whatever else. And so that's why you see a lot in the TCP UDP bucket, and then less. Although YouTube is a pretty big chunk of it, but yeah, if you click over here, it's everybody. This is sort of where you'd get top talkers and stuff like that from, right? As in, this is everybody. This is how much traffic. Looks like this one user is, using quite a bit of the overall bandwidth.
Oh, I forgot to tell you, I need delta in there too. So I just need the, minus everything else. So I need the other.
Sure. That's all yours, man.
Just a kind of a fringe question.
Sure.
When you're doing analysis of HTTP, are you including QUIC in that as well?
So the analysis was actually at the TCP UDP layer in this one, right? In this example. So QUIC would be a different layer 7 protocol, right?
Well, QUIC is essentially HTTP over UDP instead of TCP, but it's becoming increasingly popular with things like Google services and the like.
Gotcha, okay.
And so I'm just wondering whether it recognizes it independently, recognizes it at all, because that, with Google services and various other services coming into play, that can throw off your metric.
Gotcha, okay. So this is at layer 4, so we'd see the UDP part of it. We don't do, so it was an interesting question of whether we should do HTTP analysis or let's say QUIC analysis, right? The way we kind of viewed it was most apps today are encrypted, right? They're over SSL. And so all that stuff would look like a black box to us anyways. And so if we're going to do any kind of performance monitoring or performance analysis, it has to kind of be at layer 4 because that's the only layer that's visible to us. So that I assume would be true with QUIC as well.
Okay.
Yeah. But
so that begs the question. You say you're doing deep packet inspection. In my mind, deep packet inspection is defined as everything above layer 4. I mean, is that a fair question?
No, it's fair.
All right,
Yeah.
we're doing.
I mean, otherwise you're just doing packet inspection.
Yeah, we're shallow packet inspection.
I mean, you're looking at
Now you tell
standard
me.
5 tuple, but in my mind, that's not deep packet.
So the only deep packet you could say is that to identify certain applications, you actually have to look for certain signatures. Like, okay, the 10th bit in the packet is this value or something like that, which tells the app ID engine what app it is. So that's probably the only example of deep packet inspection. Otherwise, it's really around the header information and analyzing that stuff. So, yeah. But the reason we decided, to build sort of this capability to analyze packets is because a lot of the state information that we have to keep about clients in order to measure all of this stuff, as well as the ability to have some velocity too. So everything is cloud managed, right? So the user doesn't ever SSH into our box or anything like that, right? Or everything is managed from the back end. And so, if we wanted to start detecting a new kind of application, let's say quick, right? We wanted to start detecting it, and we wanted to do like a special type of analysis for that protocol. That's an easy update from our cloud. We automatically start collecting it. We can kind of go sort of move very quickly with that. Versus, with NetFlow and things like that, what we find is that there's a limited set of data there. And, we can't wait around for Cisco or someone like that to update what they put inside that. But and maybe a question back to you guys is what kind of solutions do you use typically on the access networking side? And what do you guys think overall? What you've seen and sort of compared to what
offices don't make money.
Okay.
I've been told that.
Yep. Offices don't make.
Yeah, I mean, well, when your phone system goes down, give me a call. And you can't take support calls anymore.
Poor users.
NetFlow's huge for us.
Okay.
I mean, flow analytics, understanding, what traffic is going from where, and then combining that with security data so that we know when people go to bad places.
Okay.
That's big. And NetFlow is going to give you source destination port protocol.
Yep. Anyone else?
So the sales pitch part of this is
sure.
We want, if any of you have anything, yourself, customers that want to try this, smaller deployments are not, so we have some people say, can I put it in my lab? The truth is this isn't really a solution for that. It just, I don't know. It's like getting a Ferrari and just having it in the parking lot. It just doesn't, it's like, hey, it looks pretty, but it doesn't do anything for you. So we do have demo accounts to actually what you see here that we can give out. If you have customers, we are very POC driven. And the reason behind that is people want to see their own data with this. It's not, I'm not going to call you and say, hey, buy it without trying it. So my email's up here. It's very simple. I'll put it over there for you guys, gt@nyansa.com. So if you are interested in a demo account, if you're interested in POC maybe for your customer or yourself, let us know. We're super no obligation type. We kind of feel like once you guys see what it can do on your data, that we have pretty good success after that.
I guess the challenge that I'm seeing with it is that I currently spend so much time in the data center and the WAN that the campus is kind of, if that makes a weird kind of sense.
It's interesting. It's one of the reasons we went to the campus a little bit.
Yeah.
As in sort of a contrarian.
Yeah. That's not a criticism. It's just that right now campus is not a focal point.
Yep.
But I also see that if I had a distributed sort of like a multi-vendor campus, where I had a bunch of wired stuff happening, and then I had a bunch of wireless, and I had some different wireless vendors, and I had the misfortune to have a bunch of different wireless controllers and incompatible wireless products, because they don't actually follow open standards as an infrastructure. Sure, between the client and the anyway, you know what I mean.
Yeah.
I think this would be very, very powerful and would be very useful. But right now the campus networks, the focus around digital transformation that we see is focused on different aspects, and I'm not. So for me, I just have to sit down and think about this really hard to say, campus networking is still a thing, right? And people care. about it, but we don't hear much about it. Like it's not.
But that's probably just a perspective of what you do, right?
I think so. Yeah. I
mean, guys, I can say for what we hear is it's, Knox are taxed. They have all these problems they're trying to solve that they never knew. They have no visibility. So on the flip side, we're seeing a lot of problems on the campus side.
Yes. Sorry, I'm not saying that.
No, I know, I understand. I'm just saying that it's all about
room of
perspective.
network engineers, right?
No, it's totally.
We avoid the help desk like the plague. Right? I mean, I don't want to talk about client issues, right? So this may not be the perfect audience because I'm only going to care about an issue if there's more than one person affected by it.
I mean, but
because
again,
if there's only one person affected by it, it's almost certainly not the network.
But it does. And if you guys are doing service providers, that does kind of transcend the campus because if you're able to look into the last mile, this is not just a campus thing or it's a this thing. It's you can measure a user experience from any set of users apparently and get metrics out of that.
Yeah, no, definitely.
What I see with my customers, I'm on the consulting side. My customers span a wide range of industries, sizes, et cetera. User issues take up a good part of their time. It depends on who's having the issue. So it starts out at the help desk. If the help desk can't solve it or enough people are calling, then that takes their time away from doing meaningful work, is trying to figure out why the president isn't getting the same Wi-Fi performances at their house.
And again, the user side, what I want to maybe clarify or just restate is we are very user-centric, but we look at the network. The users are almost our network measurement. Where you guys are using, right now your network managers are using SNMP and you're looking at NetFlow as your measurement of what your network is doing. We're measuring your network. We're just measuring it off of what your users are doing. So while there is one certain case that is, if an end user is having a problem, we can solve that. But I would say 2/3 of our cases are what is the network doing from the perspective of this group of users. So again, I don't want to box us into that just single end user support role. Although that's a big part, it's not. It's definitely not the whole picture.
Well, and something that you mentioned earlier, and I think someone tweeted about it. One of our, I forget. Anyway, was the proactive side of this. The fact that you give us the tools to be proactive about this.
We have a customer that I just met with 2 days ago. They have a goal of reducing incoming calls to help desk by 60% in 2017. It's a big number. It's a ridiculous number. But we think we can help with that because what they're going to do is if a customer has a problem, a different location, a different site, they will place the phone call and say, we are aware. That counts as we're solving a problem before they know about it. And again, that's what's great about, I know I'm sales pitching here, that's what's great about baselines and deviations is as you watch that slowly start to go up, you can start catching it before you get into a red or a P1 state. So you can kind of watch it get there and then start knocking those down first. And it's sorry, I'm rambling. It's an interesting thing is when you start being being more proactive, your people are taking less calls, which means you have more people to be more proactive. It's actually a snowball in the right direction once you can get that ball rolling.
I think what we see sort of from talking to customers is that on the campus side, the thing that makes it interesting and challenging is if you have wireless and if you have BYOD, right? If you have an initiative to sort of transform to have wireless performance and support any kind of device on that and applications that are used there. So companies that have those kind of initiatives and care, right, about those initiatives succeeding and kind of just want to move completely away from wired, then you sort of get mind share, right? But otherwise, it is true to sort of, we do contend a little bit sometimes with the whole campus is a cost center and nobody cares about those users, those riffraff users.
Right. But that's why we're doing well in healthcare.
Right.
I mean, a bunch of clients, bunch of wireless.
No, it's true.
Those are, that's, and it's, critical.
It's true. So verticals where either you have powerful users, like to your point, right, that will make a big stink if they have poor performance on their, Android or their Galaxy 7 or whatever, right? or places where the users are critical to the business as well. So IoT devices are now like coming up more and more as well in terms of in retail. Like
it's the new campus.
Right, exactly.
The next gen campus is IoT, really.
So you know, things are changing there. But yeah, no, totally take your guys' point about the campus versus the data center.
Yeah, because it's sort of, all of my work is following the big trends.
Yeah.
And the data center's kind of dying down. That's a solved problem, sort of. And SD-WAN's the big hotness.
Right.
So that's kind of, so it's like this would be hugely valuable for some people that I know, but the campus isn't the focus for them. That's I was just giving you that feedback.
Yeah.
No, it's good. It's good. It's a good perspective to have.
Yeah.
Absolutely.
I wanted to make sure I understood exactly what it meant.
I was just going to say that IoT was one of the reasons I was asking about scaling. So you think of, and you were mentioning a university, and you think of the a number of sensors that are going to need to be there on active shooter, emergency notifications to sense that, healthcare, etc. The energy.
The whole system is, with the newer software architectures, everything is horizontally scalable. So what that means is just you have more devices or more users that you have to support. We just add more servers at the back end, and that's it. And it just scales. And you know, it's, for some of our enterprise customers that come to us and say, hey, can you scale? We have 100 sites globally with 50,000 or 100,000 users or whatever it is, right? And you know, our response is actually, to us, we actually support all our customers all at once, right? It's a multi-tenant system in the cloud. So in that sense, we support, you know, almost 3 million users today, right? 3 million client devices that we're looking at. And that kind of looks like one customer to us, except with different sites in some ways, right?
Do you have, is this your own cloud that you're doing, or do you rent space in it?
We're deployed on Amazon, in Amazon AWS for the public cloud version. Mm-hmm. But then the hybrid SaaS one would be in a customer's private data center.
Okay.
Any other questions, thoughts?
You mentioned wireless controllers supporting Cisco and Aruba right now.
Yeah.
Any plans to integrate something like cloud-based wireless controllers? I mean, obviously, I think
like Meraki.
Like Meraki, yeah.
Meraki and AeroHive. The stock answer right now is we're very customer driven. Now, there's two pieces of that answer. Some vendors, and I'm not going to mention all vendors, don't give us the metrics that other vendors do. We picked Cisco and Aruba for two reasons. One, they own together 70% of the market. But the second thing is they do give us great metrics. We have found through experimentation and testing that we always don't get great metrics from other vendors. So if we have a customer driving case that says we want this vendor and we haven't tested it, then we go through the next step, which is, do they give us the metrics that we would need to be able to provide our service?
Okay.
Okay. I do think this is incredibly valuable if you're managing it. Just gathers all the client stuff into one space. And like Yvonne says, it's really like one user, that's not even going to get over the noise threshold, right?
Yeah.
But at the time that you need to dig into that one user, then this is going to tell you 10 users in an area are having intermittent problems.
Yeah.
And I think is where the...
Exactly. I think GT might have mentioned it, but we treat client devices to solve those kind of issues as sensors.
Yeah.
Right? So, you can think of synthetic testing as an example, right? Where you put a well-behaved client in your network that synthetic tests out to something, and then you measure the performance, and you can kind of see how that well-behaved client works, right? What we find, though, is that with wireless, it's hard to simulate. With wireless and BYOD, it's really hard to simulate that with a synthetic tester. How do you simulate, an Android running, 4.0.5 or whatever on its operating system? And how do you simulate that wireless connectivity when he's, in one part of the building versus another part of the building without having sensors literally everywhere, right? And so the way we think about it is actually, you don't need those sensors. Real users with those characteristics are actually, using applications and connecting and whatever else. And so why not treat them as sensors and then just take all of their data and kind of just put it all together, analyze it, and sort of come up with the same kind of insights.
Yeah, the analogy I use is Google doesn't send a bunch of cars out on 101 to see what the traffic is like, right? That would just add to the problem, right? They're just listening to the traffic that exists and then, making determinations based on that.